Today's video is on linear modeling day 1. So an equation whose graph is a line is obviously called a linear equation. And when we set up and write a linear equation for a real-world problem, we call it a linear model. And that is what we are going to do today. We're going to write linear models based on a real-world problem. Okay, so let's read number 1. A truck rental company rents a moving truck for 1 day by charging $29 plus 20 cents per mile. Write a linear model that relates the cost, C, in dollars, of renting the truck to the number of miles driven, X. Okay, so before we write our model, let's define our variables. It looks like X stands for miles. X is the number of miles driven. And C is the cost in dollars to rent the car or the truck. Okay, so now we have to write the linear model. Okay, so it looks like cost depends on miles driven. So it's going to be cost equals. Okay, so how much does it cost? It said $29 plus 20 cents per mile. And since mile stands for X, it's going to be 20 cents X. 29 plus 0.20 times X. That's our model. And now that we have a model, we can solve it for different situations. What if you drive 110 miles? What's the cost? Well, using this model, we're going to plug 110 in for X, because X stood for miles. So cost is 29 plus 0.20 times 110. And you just type that in the calculator, and you will get your answer. So 29 plus 0.2 times 110. And it would be $51. And you want to make sure you include units on these. Now part D says, what if you have $300? How far could you drive? Well, this time they want to know how many miles X. So this time the 300 goes into C, and you need to work backwards to find X. So this one will be 300 equals 29 plus 0.20x, and you would have to draw your wall and solve. Okay, so you would minus 29, and what is that, 271? Yeah, 271 equals 0.20x, and then divide by 0.20, divide by 0.20, and you will get x. So 271 divided by 0.20 is you would drive 1,355 miles. And again, make sure you have your units. Okay, so it's really important to be able to set up a model to use it to solve different scenarios. All right, I think we have 2 more on the back. So number 2. A chemist's salary was $35,000 in 1985, and it increases $300 per year. Write a linear model that relates the salary S to the number of years since 1985. Let's call that X. Okay, so first let's define our variables. X is the number of years since 1985, and S is the salary in dollars. Okay, so let's see what we got here. So write a linear model. So salary depends on the number of years. So we're going to write S equals. Okay, it started at 35,000. And then it's increasing by, so increasing by means plus 300 each year. So 300x, because x stands for number of years since 1985. So that's our model. Now letter C says find the salary in 1991. So we're not going to plug in 1991 for x. How many years after 1985 is 1991? So you're going to have to do a little subtracting. What's 1991 minus 1985? That's 6 years have passed. So we're actually going to plug in x equals 6, because x stands for the number of years after 1985. All right, so if we plug in x, salary is going to be 35,000 plus 300 times 6. And we can just do that straight in the calculator. 35,000 plus 300 times 6, and that is 36,800. And that's in dollars. Okay, now D is the opposite. D, they're saying if you know the salary, can you plug that in for S, and can you find the year? Okay, so this is the one we go backwards. 38,000 equals 35,000 plus 300x, and you draw your wall to solve. Okay, so we're going to subtract 35,000 from both sides. You're left with 3,000 equals 300x. And then you're going to divide by 300, divide by 300, and 3,000 divided by 300, we could have done in our head, is x equals 10. Okay, but that's not the answer. What year is that? What year is 10 years after 1985? And if you just add 1985 plus 10, it will be in year 1995. That's the final answer. That's the year. All right, last one. I would suggest trying this one on your own, but again, I'm going to do it for you just in case you want to check. So a Commonwealth Edison company supplies electricity to residential customers for a monthly charge of $7.58 plus 0.8275 per kilowatt hours for up to 400. Write a linear model that relates the monthly charge C in dollars to the number of kilowatt hours X used in 1 month. Okay, so what are our two variables? It says C stands for monthly charge in dollars, and X stands for the number of kilowatt hours used. Okay, so the model, the charge is going to be based on the hours used. So C equals, all right, let's see. It's a flat fee of $7.58 each month plus 0.8275x, because per kilowatt hour, and X stands for the number of kilowatt hours. You know what? This 400 is kind of extra information. Doesn't help for our model. All right, part C. If we use 100 kilowatt hours, we're going to plug that into X and find C. Okay, so it's going to be 7.58 plus 0.8275 times 100, and that cost will be $90.30. Was it $90? Oh, and 33 cents. And then D, again, is just the opposite. They give you the cost. So this time you're going to plug 25 in for C, and they want you to find the number of kilowatt hours X. So this is 25 equals 7.58 plus 0.8275X, and this is where you draw your wall and solve. So minus 7.58 minus 7.58. 25 minus 7.58 is 17.42 equals 0.8275x, and then divide by 8275, divide by 0.8275. I'll put this over here. 17.42 divided by 0.8275, and that would be about 21. How many kilowatt hours? So about 21 kilowatt hours. You can't go over 21 or it'll be too expensive. Okay, thank you for watching.